This video is about the remainder theorem and the factor theorem. They're very closely related. And we'll also talk about how to divide polynomials that have a remainder. Let's get started. We will first use our calculator to complete the table for the following function. Okay. Now typically I would plug this function into the y equals part of my TI-84 and then click the table button and it will just give me this table. Now I don't have a way to display that very easily on my screen, and so I'm using Desmos to kind of it's a little more cumbersome, but we can do it. So I've typed in this f of x function here, and right here I can plug in and compute the value for f of x for each of these x's. So if x is negative 3, then the value of f of x is negative 300. If x is negative 2, then f of x is negative 28. If x is negative 1, then we get 0. If x is 0, f of x is negative 6. If x is 1, then f of x is 20. If x is 2, then we get f of x is 0. And finally, if x is 3, then f of x is negative 288. So those are the values I get if I plug in these x values into the function. Now, nothing super surprising there. Next, I'll use synthetic division to divide f of x, this function, by each x value in a binomial form in the table to find the remainder. So this is actually, I'm going to do some division to find the remainder. So be neat. You need to fit in all your work. So I'll focus first on x is negative 3, and I'll divide this function by the binomial that would give me negative 3 as a 0, which is x plus 3. So I'll use synthetic division because I can, and I will do negative 3 Okay, now this very last number that we focused a lot on before has always been 0 for us in the past. So this time it's not 0, but as I've said before, that this last number is always the remainder. Okay, so notice we get the same number here that we got as the remainder. Okay, this is still the constant term and the x term and the x squared term and the x cubed term. Okay, but notice that the remainder is the same value I got when I plugged negative 3 into the function. That's interesting. So let's now look at what would happen with negative 2. Again, I don't get a remainder of 0, but I get a remainder of negative 28, which was the same thing I got when I plugged in negative 28 into the function. Okay, these are very separate processes, right? Plugging in negative 2 into my function, and I got a number, and then dividing and getting out a number. I really shouldn't get the same number, so this actually should be a surprising thing that we notice. Okay, for the sake of space, I'm going to erase and do just 2 more of these to show you what happens. This time I did get a remainder of 0, which means this divides it evenly, but also that this remainder was the same thing I got when I plugged x into the function. Let's look at one more. Okay, and the remainder I got was negative 6, which was the same thing I got when I plugged in x equals negative 6. Okay. So we notice a pattern. I could keep going here, but for the sake of time, what you will get every single time is that the remainder, when you divide a function, the remainder you get is the exact same as the value you get if you plugged in that, that 0 that would be there, so that the negative 3 or the negative 2 or the 1 or the 2, if you plug that number into the function, you would get the exact same thing as the remainder. That's a pretty, surprising and astonishing finding. Okay, so this is the remainder theorem. let p be a polynomial function in x, and let a be any real number. Then there exists a unique polynomial function q such that p of x is equal to that unique function q of x times x minus a plus the remainder, which is p of a. What that means is, let me change colors here. So what that means is if we divide by x minus a, then you can calculate the remainder by finding p of a. By plugging in a into the function p, you could find the remainder of that, what you would get if you divided. So this is very similar to, very connected to the factor theorem. So again, let p be a polynomial function in x and a be any real number. If a is a 0 of p, then parenthesis x minus a, that binomial, is a factor of p. So the factor theorem is pointing out, kind of an extension of the remainder theorem, that if a is a 0 of p of x, meaning if I plug in p of a gives me 0, then that means that x minus a would be a factor of p. Okay, because the remainder is 0, and if you divide and get a remainder of 0, then that binomial is a factor of that original polynomial. So let's use the remainder theorem and the factor theorem in a couple of problems to either find the remainder and the quotient. So first, we will determine if the divisor is a factor, and then second, determine what the quotient is. Okay, so I can figure out in number 1 here, in letter A, if the divisor is a factor by plugging in -3, I'm going to change the signs, -3 into this function and seeing what I get, and that would be the remainder. And I get 0. That means when I divide these polynomials, I should get a remainder of 0, which also means that x plus 3 is a factor of this polynomial. Now, let me show that to you, what you would get with this synthetic division. And you do get a remainder of 0. That shouldn't be surprising by this point. Okay, and keep in mind that this is the constant term, the x term, and the x squared term. So if I divide these, the quotient that I get is 2x squared plus 3x minus 7. Okay, but it also means that I can rewrite this function as 2x squared plus 3x minus 7 times x plus 3 with no remainder. Okay, so that's that first one. In letter B, let's also look at what the remainder is going to be using the remainder theorem. So I'm going to plug into this function the number 4 into R. Okay, and I get -2, which means when I divide these, I should get a remainder of -2. It also means that r minus 4 is not a factor of the polynomial. Now, a new thing is, how do you write this quotient so that we have a remainder? That's a new thing. I've not seen that yet so far in this class. So as I do my synthetic division, I do it the same way I've always done it. And I get a remainder of -2, which shouldn't surprise us by this point. So to write out the quotient of this, dividing the polynomial by x minus 4, I get, this is still the constant term and the r term and the r squared term, because I'm in terms of r. I get r squared minus r minus 7, here's the new thing, minus 2 divided by this polynomial, or this quotient, r minus 4. Okay, that's what I get when I divide it. So if there's a remainder, you can write it as that remainder divided by the binomial that you divided by. All right, this video introduced the remainder theorem and the factor theorem and talked about how to divide polynomials that have a remainder. Thank you for watching.